Okay, so in this video, what we have is a system of equations in three variables, three unknowns. And what we're going to do is take advantage of technology to find what's called the reduced row echelon form of the matrix, which is just basically a fancy way of saying get as many ones and zeros in place as you can. So after using technology and putting this system in matrix form, the reduced row echelon form we get for this particular system of equations is sitting right here. So from that, we can get an idea of what the solutions look like, because you notice this looks a little bit different than what we're used to. That bottom row is missing the 1. So if I translate this back into the original system of equations, I get x plus z equals 12, and y equals 6, and we get the equation 0 equals 0, which, remember, doesn't tell us that much because we already know that 0 is equal to 0. So that's kind of a non-equation, really. That's really not telling us much information. What we do have there is we have two equations that spread across three variables, which, remember, always used to tell us that there was infinite solutions. So the goal of this course, and what we use the matrices to get to, is how to write those infinite solutions. So the first thing to notice is that we got y equals 6, which means no matter what my solution set is, I already know that y has to be 6. Okay, so 6 is going to show up in every single possible solution to this system of equations. What we also get is that x plus z is equal to 12. So I'm actually going to take that and I'm going to write one of the variables in terms of the other. And I'm going to write x equals 12 minus z. So what that means is if I have a solution of the form x, y, z, I can write this as, and trying to write it in as few variables as I can. I know that x is 12 minus z from what I just found. I know that y is always 6. And I know that z is just whatever z is, right? So there is one way to write the solution to the system. So what that means is, if I just pick arbitrary values for z, I'm going to say z equals 0 for 1. That's going to give me the solution 12, 6, 0. And if you substitute that into each of the three equations above, it's going to work in all three. It's a solution. But what also happens is, what if I let z equals 1? That's going to give me 11, 6, 1. That also is going to be a solution to all three equations. So what we're doing is kind of generating all these possible solutions. So for any value of z that you can think to plug in, and you can plug in decimals, you can plug in fractions, you can plug in anything you want to, there's a solution corresponding to that. So using the matrix technology and getting that final matrix gets us, a better idea and a quicker way to get that idea of what the solution set really is. So hopefully that helps, and what we're going to do at some point is look at an application in which this is true. Because some business applications out there, we're not always furnished with as many equations as we are variables, so we have to get creative with what solution to use. So we'll see more on that in a moment.